Hello dear students, welcome to the channel Pen and Paper Chemistry on YouTube. The lesson that we are going to take up now is electrochemistry and specifically the numericals based on this. So for that, what do you have to do? Yes, please quickly fetch a pen and paper so that you are able to do the numericals yourself, and as we say, it is always learning by doing. I am going to discuss around 5 numericals in this particular topic so that your concepts are clear in it. A very good habit before we start with doing the numericals is a quick recap of the formulas that we have learned till now in the previous video that we have already discussed. So here what we've done is I have tabulated it into 3 columns: the physical quantity, formula and unit. By the way, you can do the same thing for other topics as well, and you can paste a chart close to where you study so that you can read these formulas day in and day out, and they become embedded in your mind by the time you sit for your examinations. So a quick recap: we have current, I is equals to charge upon time, unit is ampere, resistance denoted by capital R, potential difference upon current, unit is ohm, resistivity is R into A by L, where A is area of cross section and L is length of the conductor. The unit can be ohm into meter, or it can also be ohm into centimeter. Conductance is reciprocal of resistance, unit is Siemens. Conductivity denoted by kappa, a small k, 1 upon rho, that is 1 divided by resistivity, unit is Siemens per centimeter or Siemens per meter. Molar conductivity is conductivity into 1000 divided by the molarity of the solution. Now why 1000? Because we've converted the liters into cc, centimeter cube. So Siemens into centimeter square per mole. What you have to remember in this particular formula is that you will put only the numerical values. You won't convert the molarity into the number of moles per cc. It has already been converted, it has already been taken care of in this particular formula. So you just have to substitute the values. Cell constant, that is denoted by G asterisk, that is L by A, the length of the electrodes, or sorry, the distance between the electrodes, and A is the area of cross section of each electrode. This is also equal to the conductivity upon conductance or resistance upon resistivity. So the things become a little easy for you. So what we can also write over here is that conductivity is cell constant into conductance. Conductivity is cell constant into conductance. I hope you are writing down these formulas, and if you have written them down once, half of the task is already done. Unit for cell constant, L divided by A, so you will have per meter or per centimeter. So are we ready to do the numericals? Now the numericals are framed here keeping in mind moving from a simple to a more complex task. That's how we are going to do. Yes, I can see that you've already started doing the numerical, which is a very good sign, because most of the students, they shy away from numericals. So that's why I'm going to tell you easy ways to do it. Now if you notice in this particular question, it says you have a solution A, you have a solution B, and in brackets their molarity is provided to us. One is 0.1 molar, the other solution B is 0.01 molar. So be very careful of the values which have been provided to you. Conductivity values of each of these have also been provided to us, 4.5 into 10 to the power minus 4 and 3.5 into 10 to the power minus 2. So let us first write down these values into the language that we know, right? So we have solution A, we have concentration is 0.1 molar. This is the data that I can derive. Conductivity is kappa, 4.5 into 10 to the power minus 4 Siemens per centimeter. So it's already been taken care of. What do we have to calculate over here? Molar conductivity. Now if you go back to the formula chart that we had drawn, kappa into 1000 upon the concentration gives you molar conductivity. So can you do the calculations over here? I am not giving the answer right away. I would expect you to solve it. Solution number B, again concentration is provided to you as equals to 0.01 molar, and you have kappa equal to 3.5 into 10 to the power minus 2 Siemens per centimeter, right? So molar conductivity, again kappa into 1000 divided by concentration. From the data provided above, determine the molar conductivity of each electrolyte and infer which is a better electrolyte. So which would be a better electrolyte? One with higher molar conductivity or one with lower molar conductivity? We know that electrolyte is supposed to conduct. Yes, the one with higher conductivity would be a better electrolyte. We would come back to the answers of this, or would you want me to give the answers to you right away? Please try the question yourself. You can always see the answer later on. So we get the answer for the first part as 450. S stands for Siemens centimeter square per mole, right? So similarly, what will be the unit for the second one? Perfect. S centimeter square per mole. So out of the two of them, which is a better electrolyte? Definitely it is B, which is a better electrolyte. Now when you are attempting these numericals, make sure that you write the answer to the question which has been provided. Now in this particular question, there are two parts. Determine the molar conductivity of each electrolyte. So you get half of marks for these, and infer which is a better electrolyte. So supposing you leave your answer up till 450 and 3500 with the correct unit, of course. Without the unit, these values have no meaning at all. So half a mark for the correct answer with the correct unit, half a mark for the correct answer with the correct unit. And which is a better electrolyte? So B is a better electrolyte because of its higher molar conductivity. So when you write that, you get another 1 mark. And that is how we grade the students in terms of their marking scheme. So are you ready to go on to the next question? Perfect. Second question says a 7.5 into 10 to the power minus 3 molar solution of KCl. I'm reading it out for you just in case there is any confusion in the writing. Solution of KCl in a conductance cell at 298 Kelvin was found to have a resistance of 1000 ohms. There are 3 zeros. Calculate. First part, conductivity of this solution. Second part, molar conductivity if the cell constant is 1.25 per centimeter. So let's go ahead with this question. Would you like to jot down the values which have been provided to you, what all data has been provided to you? So we know that the concentration of the solution here, yes, 7.5 into 10 to the power minus 3, go ahead. So C is 7.5 into 10 to the power minus 3 molar. Do we need temperature? Yes, let us jot it down, there is no harm. This is the data which has been provided to us. Resistance is found to be 1000 ohms, or you can also write it as 10 to the power 3 ohms. Calculate the conductivity of this solution. So you have to determine kappa and molar conductivity of this solution, again lambda m, if the cell constant. So you have been provided G asterisk or G star is 1.25 per centimeter. Now in the chart, from the chart, which formula can you recall which you can apply over here? Go ahead, tell me. There is one relation that we wrote by hand between conductance and conductivity. Go ahead and see it. So you see over here, conductivity is cell constant into conductance, and what is conductance? Reciprocal of R. So would you like to apply this formula in order to determine kappa? Go ahead then. So what do we have over here? Kappa is G into G asterisk or G star, or what I have written as cell constant to make things easier for us. Yes, G star is our cell constant. Let me write it a bit more clearly. There we go, right? And this is equivalent to, yes, it is equals to L upon A. Now what is this G over here? This is 1 by R, and the cell constant value we note as 1.25. So when you put the value of R as 1000 into 1.25, we can simply put the value of kappa as 1.25 into 10 to the power minus 3. What will be the unit? Very good, Siemens per centimeter. Now once you know conductivity, can you determine molar conductivity? We have just now done in the previous question the relation between the two, that is kappa into 1000 divided by the molarity of the solution. Go ahead, calculate. I will give you the answer later on. I am not giving you the answer right now. So you see, this is what I meant. We are moving from simple to a little more complex. With every question we are adding a new value, so you don't have to panic about numericals at all. Okay, question number 3. This is a pretty simple question. If you see, it's a very direct question. The question says the conductivity of a 0.02 molar solution of KCl was found to be 0.245 Siemens per centimeter at 298 Kelvin. What is its molar conductivity? Oh yes, I like that confidence on your face that yes teacher, I can do this question myself. It's simple direct formula. Only thing you have to be careful about is the decimals and the division. Should I leave it for you to solve it? I can always come back to it to give you the answer. If you are done with the third question, let me introduce you to a question where we are going to try and correlate all the values, physical quantities that we have learnt till now in electrochemistry. We are not yet done with the topic, so there are more to go. We shall do it after these numericals. So question number 4, it says 0.5 molar solution of an electrolyte when placed between two inert electrodes 2 centimeter apart have a resistance of 30 ohms. Determine first part cell constant, second conductance, third conductivity, 1/4 molar conductivity of this electrolyte if the area of cross section of the electrodes is 3 centimeter square. Lot of information that has been provided, but there's a lot that is still missing. Let's jot down what is provided to us. 0.5 molar solution. So concentration is 0.5 m. When placed between two inert electrodes 2 centimeter apart, so the distance between the electrodes is 2 centimeter, has a resistance of 30 ohms. So the resistance of the electrolyte is 30 ohms. Determine the cell constant. So we have to determine cell constant, conductance, conductivity and molar conductivity if area of cross section of the electrodes is 3 centimeter square. Now all this information has been provided to us. We've used all of it. Now determine cell constant. That means we have to determine G asterisk. Conductance. What is the symbol for conductance? G. So we've got to determine G star, we've got to determine G, we've got to determine conductivity, that is kappa, and molar conductivity, that is lambda m. So 4 values. Oh my God, how are we going to move about it? Let's start with the first thing. Cell constant. G asterisk or G star is L upon A. Yes, very good. Okay, G is 1 by R, that is the reciprocal of resistance. So we are done with A part, we are done with the B part of the question. Now we go on to the C part, kappa. Can you recall the relation between kappa, conductance and cell constant? Yes, we did it a while ago. We saw it in the chart as well. Go ahead. I'm leaving it as a blank for you to fill. Do it. Try recalling. Don't jump to the chart right away. Oh, let me see. Put a little flashback in your memory and you'll get the answer. And of course, the fourth one is an easy one, molar conductivity. We have used the formula so many times now and I'm sure you must be familiar with it. Go ahead, solve it, pause the video, solve these numericals. So are you ready to do the last question in this particular lesson? Of course, this is not exhaustive. I have just tried to take up as many different types of problems that we can in this particular lesson. The conductivity of a 0.01 molar solution of KCl is 1.40 into 10 to the power minus 3 Siemens per centimeter. Sorry for this not being as a superscript. It's a typing error at 298 Kelvin. It offered a resistance of 450 ohms in a conductivity cell at the same temperature. The same cell is now filled up with a 0.001 molar NaCl solution at the same temperature. The resistance measured is 5400 ohms or 5400 ohms. Determine the molar conductivity of the NaCl solution at the given temperature. So let's first jot down the values which have been provided to us. So if you notice over here, we are talking about two substances or two electrolytes, KCl, yes, and NaCl. The concentration of the KCl solution is 0.01 molar. And its conductivity, that is kappa, has been provided to us as 1.4 into 10 to the power minus 3 Siemens per centimeter. Always remember, without the units your answer has no meaning at all. Many times I have students who come up and say we did not get marks although our answer is correct. That's because the unit may be missing. Without the unit, your answer will have no meaning at all. It offered a resistance of 450 ohms. So R is equals to 450 ohms. Now how is this information helpful? Because we know the resistance of this, we know the conductivity of this, we can determine what? Very good. We can determine the cell constant. Now, using this cell constant, we replace the NaCl in the solution, KCl in the solution by NaCl, the concentration of which is 0.001 molar. See, the cell constant will not change even if you change the electrolyte. Now here the resistance is 5400 ohms. You have to determine the molar conductivity. Now for molar conductivity, we know that we need to know the conductivity of the solution into 1000 divided by the concentration. So just to distinguish between the two concentrations, let's put a small 1 and 2 at the bottom so that we know which solution we are talking about. Because you want conductivity over here, conductivity is the cell constant into 1 by R, correct? And how do you determine cell constant over here? Try it. Did you try it? Do you think about it? Very good. The formula is anyway provided to you over here. So what do we have is conductivity is cell constant into the reciprocal of resistance. What is the reciprocal of resistance? It is conductance. So you will get the cell constant from here, and that same cell constant will apply in the second solution, that is NaCl. Please try and solve it. So what is the use of the conductivity value given to us over here? Are we using it? Yes, we are. Here. Temperature has been provided additional just to let you know that the measurements are being done at the same temperature, because we know that the conductivity does change with the change in temperature. C1 is something which we have not used and is not required to be used in the question as well. So give a pause to the video, try and solve these numericals, and then we'll come back to the answers. So providing you the answers to the questions here. Question number 2, we have molar conductivity as 166.67 in Siemens centimeter square per mole. You got this right? Give yourself a big smiley here, pat yourself on the back. Let's do the third one, the value for molar conductivity, because this was a very direct question. 12250 Siemens centimeters square per mole is the molar conductivity. Got the second one right? Very good. So let's give ourselves 2 smileys and 2 pats on the back. How about the fourth one? Cell constant is 0.667 per centimeter. I hope you are not forgetting the units. Units are very, very important at your level of learning. You cannot ignore the units over here. Conductance 0.033 Siemens. That's the reciprocal, which we also introduced as per ohm. It's SIEMENS. You can also write the short form as S. Then we have conductivity, that is 0.022 Siemens per centimeter. Molar conductivity is 44.44 Siemens centimeter square per mole. Have you got all of them right? Oh, 3 right. Fourth one, there is a difference in the decimal. No problem, you can always go over the question again, and you can now give yourself smiley to the power of 3. Let's go on to the last question in this series. We've got the value of the cell constant, which on calculation comes out to 0.63 per centimeter, and we apply this value to the second solution, that is NaCl. Our conductivity comes out as 1.167 into 10 to the power minus 4 Siemens per centimeter. Molar conductivity is 116.67 Siemens centimeter square per mole. And there you have your 4th smiley for the day. So to the power of 4. I hope you will like and enjoy doing the numericals now. Look out for the next video, because we shall be talking about Kohl-Rosch law in it. See you later. Stay happy, stay calm, and stay smiling. Happy studying to all of you. Do subscribe for more videos in chemistry, and don't forget to share the channel with friends and classmates. See you in the next video.